let the fun continue. Chapter 2, Section 1. This is the second day of this lesson. We'll finish it up today. And I think this is just about parallel and perpendicular lines. And this is something you just had this last year in geometry, so this shouldn't be too bad. Slope can be used to determine whether two non-vertical lines in a plane are parallel or perpendicular or neither. So two distinct non-vertical lines are parallel if and only if their slopes are equal. That is, if the slope of one is equal to the slope of the other, then the lines are parallel. Two non-vertical lines are perpendicular if and only if their slopes are negative reciprocals of each other. So it says m sub 1 equals negative 1 over m sub 2. That just means if you got 1, let's say the first slope is 1/4. The perpendicular slope is going to be flip this upside down and change the sign. So if I flip that over, it becomes 4 over 1. This was positive, so this would be negative. If I have a slope of negative 7/8, the perpendicular slope would be flip that over, 8 over 7, and change it to positive. So these lines with these slopes would be perpendicular lines. They are going to cross somewhere at a 90-degree angle. So here it's all about slope. So in example 4, find the slope-intercept forms of the equations of the lines that pass through this point, and A, that are parallel to, and B, perpendicular to this line. So this is the line we're starting with, and we're going to find parallel and perpendicular to this line that pass through a given point. So the first thing we should do is take this line and get it in the slope-intercept form. So I'm going to take this 2x and I'm going to subtract it from each side. Negative 3y equals minus 2x plus 5. And then I'm going to divide by negative 3. So I'm going to have negative 2 divided by negative 3 is positive 2/3 x. And then we're going to have minus 5 divided by 3. 5 divided by negative 3, that negative overpowered that positive sign. And don't worry about this fraction, because the big thing here, it's all about the slope. This is what we're concerned about here. This slope is what we're after. Now, when we come over here, we have a given point, 2, comma, negative 1. So for part A, we want a parallel line. So if we want a line parallel to this one, this line had a slope of 2/3. What slope do we want for this line we're about to write the equation of? Well, if they're parallel, that means the slopes are the same. So we want to use the same slope, 2/3, and we want to use this point, 2 comma negative 1. So let's write our equation. Y minus this negative 1 is equal to the slope 2/3 times x minus this x value 2. So on the left, y minus a negative 1 becomes y plus 1 equals, we'll distribute that 2/3, 2/3 x. 2/3 times negative 2 will be minus 4/3. And our last little step, let's subtract 1 from each side. Y equals 2/3 x. We're going to subtract 1 from each side, and 1, another way to write it would be 3/3. So we're going to subtract 1 here. This is gone. We're going to subtract 3/3 from this side since we have a common denominator 3. So minus 4/3 minus another 3/3 is minus 7/3. There's our answer for part A. It is parallel to this given line, and it will pass through the point 2 comma negative 1. Let's do part B now. Part B says they want a perpendicular slope. So B. We want to be perpendicular to this line. So here, if this slope is 2/3 and it's positive, the slope of our perpendicular line will be 3/2 and it will be negative. And we're going to use this same point. So y minus negative 1 equals m negative 3/2 times x minus this x value 2. So it's exactly the same as the last problem, but now the slope is different. It's the negative reciprocal. So on the left, we still have y plus 1 equals, distribute here, minus 3/2 x, and then this negative and this negative will turn into a positive. Positive 3 over 2 times 2 over 1 is 6 over 2, which works out to be a 3. And just like last time, we're going to subtract 1 from each side. So subtract 1 from here, we're going to have minus 3 halves x plus 2. So there's a line. It is perpendicular to the given line, and it again passes through this point. Alrighty. Applications. In real life problems, the slope of a line can be interpreted either as a ratio or a rate. If the x and y axes have the same unit of measure, then the slope has no units, and it is just a ratio, a comparison of two numbers. If the x and y axes have different units of measure, then the slope is a rate of change, or a rate. And here's an example for maybe this x-axis is units measured in miles, and this is also measured in miles. So maybe our slope, we could say our slope is up 2 over 2. So our slope is 2 miles over 2 miles. And the 2's would reduce down to 1's. And the miles, you could say they canceled out. So here our ratio is 1 to 1, because we have no more units. Those units did cancel. And oops, if we did it this way, maybe our x-axis is in miles, but our y-axis is in, let's make this miles, and let's make our x-axis in hours. So let's see, maybe we had this, it was up 10 over 3. So our rise was 10 miles, and let's make it 2. And our run was 2 hours, so we divide the numbers. 10 divided by 2 is 5. And now we have numerators per denominator. Miles per hour. Miles per hour. So if the units are different, it is a rate of change. When you're cruising down the highway at 5 miles per hour, that is your rate of change. For each hour that you travel, how many miles have you traveled? 5 hours. 5 miles per hour. Here's some neat real-life data. It comes right from the American with Disabilities Act handbook. If you're going to open a business and it's open to the public, you have to conform with the ADA, and here's one of their stipulations. The maximum recommended slope for a wheelchair ramp is 1/12. A business is installing a wheelchair ramp that rises 22 inches over a horizontal length of 24 feet. Is the ramp steeper than recommended? So, let me see if I have a triangle tool here. Yes. So, put it this way, I guess. And it says it rises 22 inches, so the ramp went up 22 inches over a horizontal length of 24 feet. Is the ramp steeper than recommended? We want our slope, RM, to be less than or equal to 1/12. That's the maximum that it can be. So our ramp has to be equal to that or less. So let's figure out. Do you notice something here with the units, though? We're in inches here, we're in feet here. So we could change this into inches, or we could change 22 inches into feet, or we could change this feet into inches. Let's change to inches. There's 12 inches in a foot, so 12 times 24 is 288 inches. So what is the rise of our ramp? Our rise is 22. Our run is 288. And we could reduce this, I guess, but it might be easier just to compare decimals. So let's bust out the calculator. Where's my calculator? Right there. 1/12 as a decimal. 1 divided by 12 is 0.083 repeating. 0.083 repeating. So that's, our slope should be less than or equal to that. Let's see if our slope is. 22 divided by the 288 is 0.0763. So our slope was about 0.0763. Did we conform to the ADA? Yes, our slope is, or our ramp is less steep. Okay, example 8, predicting sales. So sales for Best Buy were approximately $35.9 billion in 2006 and $40 billion in 2007. So in 2006 we sold this much, and it went up in 2007. Using only this information, write a linear equation that gives sales in billions of dollars in terms of the year. Then predict the sales for 2010. So let's see. What do we have here? Basically 2 points. And let's see. How should we do this? Yeah, these are 2 points in the plane. So our input is 2006. That's like an x coordinate. And our y value, our sales, is 35.9. We just got to remember that's in billions. And then we have another point. 1 year later, in 2007, our sales went up to 40 billion. 40.0 billion. So it says write a linear equation. We have 2 points. What can we find if we're given 2 points? Well, we can at least find the slope. So let's find the slope. We can't write an equation without slope. So the numerator is the change in y values. Here it's going to be 40 minus 35.9. 40 minus 35.9 over 2007 minus 2006. 27 minus 2006. So we subtract our numerator and we get $4.1 billion divided by, the difference down here is 1. So our slope, our m, is positive 4.1 billion. Okay, so we have, I'm going to come up here, our m is equal to 4.1. So now we need to write a linear equation. Do we have everything we need? Yes. You know, we have the slope, and we need at least 1 point. We actually have 2. So it doesn't matter which one you pick. You could write your equation using this one or using this one. Now remember, we're going to plug that into y minus y sub 1 equals m, quantity x minus x sub 1. So which point do you want to use? Just looking at these, I really like that 40.0. That's much better than a 35.9. So I am going to work with this one. If you work with the other point, you will get the same correct answer at the end. So here we're going to have y minus 40 equals m, and our m value was 4.1, times x minus 2007. So we're going to have here on the left, y minus 40 equals, distribute the 4.1, 4.1x, and then I need 4.1 times 2007. 4.1 times 207, 8228.7. 8228.7. And then to get y by itself, y equals, we're going to have our 4.1x, and then we're going to add 40 to both sides. So we have this is a negative number here. Is that up? I just changed that to a negative, and now we're going to add 40 to each side. So add 40, and that becomes negative 8188.7. Negative 8188.7. And let's see, I guess I can clear some of this other junk out. And I'll just rewrite it a little better up here. Y equals 4.1x minus 8188.7. And then it says predict the sales for 2010. Remember, x is just the year. So if we want to know what sales might be in 2010, we plug in that for x. Y equals 4.1 times 2010, and then we subtract the 8188.7. So it's calculator time. And let's see what we have here. Let's clear that out. 4.1 times 2010 equals, and then we're going to minus 8188.7, and our answer is 52.3. Y is equal to 52.3. And let's ask ourselves, does that answer make sense? In 2006, almost 36 billion. Next year, 2007, it went up. So we should expect it to go up every year. 2007, 2008, 2009, 2010, we're up to 52.3 billion. So the answer does make sense if we continue to follow that linear growth pattern. Here's our summary of general equations of lines. Here's our general form. ax plus by plus c is equal to 0. If it's a vertical line, it's just x equals a number. If it's a horizontal line, y equals a number. Slope-intercept form, that's my favorite, the most useful, y equals mx plus b. And then we have this point-slope form. We use that a few times today. And if you want to do the two-point form, all you got to do here is we take this m and replace it with the slope formula, y2 minus y1 over x2 minus x1. So if we just replace the m with that, with the slope formula, that is the two-point form. A few practice problems here. The first one's tell if they're parallel, perpendicular, or neither. 83, find the slope between the points. The last one is write the slope-intercept form of the equations parallel to and perpendicular to the given line that go through the given points. So pause the video, try the problems, and start her back up. Okay, in the first one, we have two equations. L1 is y equals 4x minus 1. L2 is equal to y equals 4x plus 7. Are the lines parallel, perpendicular, or neither? Just look at the slope. Here the slopes are the same. That means parallel. Here, the slopes, negative 4.5 and positive 5 over 4. Or not, negative 4/5 and positive 5/4. So, are they parallel, perpendicular, or neither? If you can take one of the slopes, flip it upside down and change the sign, and you got the other, that means the lines are perpendicular. They're negative reciprocals. Oops. 83. We're just finding a couple slopes here. So our slope m is numerator y minus y. Here it's going to be 9 minus negative 1, which is a 10, divided by 5 minus 0, which is 5. So that slope is a positive 2. For the second problem here on the bottom, numerator y minus y, 3 minus 1 is a 2, over 0 minus 4 is negative 4, and then we could reduce that fraction to a negative 1/2. All right, last one. So we did an example a lot like this one. So it's actually sort of a multi-part problem. The first thing we want to do is get this given equation into slope-intercept form. So I'm just going to have to move the x over and make it negative. I'm going to subtract x from both sides. So that's going to be y equals negative 1x plus 7. And I'm going to make this negative 1 over 1. Why not? So if we want to first write A, the parallel line, A equals, our parallel line is going to have the exact same slope of negative 1. So here our m is negative 1, and we're using this point. Y minus 2 equals m, negative 1, times x minus negative 3, which turns into a plus 3. Distribute the negative. Y minus 2 equals negative x minus 3. And then we would add 2 to both sides. Y equals negative x minus 1. There's our line parallel to the given one that goes through this point 3, 2. Part B is perpendicular line. So for part B, this slope is negative 1 over 1. It's reciprocal. I'd flip that over and we'd still have 1 over 1, but now it's positive. So now here for perpendicular, our m is positive 1. So y minus 2 equals m times x minus negative 3, which would turn into a plus 3. Let's see here, distribute the 1. Y minus 2 equals x plus 3. Add 2 to both sides. Y equals x plus 5. There's our line that is perpendicular to the given line, and again it goes through this given point. I think there is one more here. Try this one on your own. Line through here that goes through this point, parallel and perpendicular. So here, you know, the line is already given in slope-intercept form. So for part A, parallel to, we were going to use the same slope, m equals negative 2. So y minus 1 equals m negative 2 times x minus negative 1 turns into an x plus 1. Distribute the negative 2, minus 2x minus 2, and then we're going to add 1 to both sides. Y equals negative 2x minus 1. That equation is parallel to the given line, goes through the given point. Now we want the perpendicular line. So this slope in the given line is -2/1. So the perpendicular slope will be, turn that over and change the sign, +1/2. So y minus 1 equals m, 1/2, times x minus -1, which turns into a +1. Distribute the 1/2, 1/2 x plus 1/2. And then we're going to add 1 to both sides. We're going to add 1 here, that's gone, and we're going to add 1 here, and let's call that one 2/2. So y equals 1/2 x plus 3/2. There we go, perpendicular to the given line through the given point. Homework for this section, page 181. If it's not already crossed out, or if it's not removed from your assignment sheet, make sure problem 73 is not on there. Again, make sure 73 is removed.